Hi, this is Takuma Nakata. I'm an instruction designer based in Kyoto, and welcome to my vvvv beta graphics tutorial. In today's tutorial, we're going to learn how to create this kind of effect. So basically two-part. One is importing a photo scan or photogrammetry or whatever 3D scanned geometry, and then adding some effects onto it. So in this one, I have an effect that the turbulence will be on when the particles from the photoscan vertices are close to my camera. So I'm going to share how I created this. I got a really nice, the reason why I'm creating this is I got a really nice feedback from a guy through Instagram, and he said he's interested in things that Refik Anadol is creating, and he's some of you might already know, but I've seen some patches from him that he's actually creating some of his work using vvvv, and he's a really great artist. I love his work, and if you go to vvvv.org, the recent on the recent video that they released, this one is also made by Refik, so I think he's one of the greatest artists nowadays to follow. So if you haven't followed him on Instagram or whatever, I suggest you to follow him. His works are great, and I know this wind, I've seen the patch from this Wind of Boston, and also he was using VVV for, I think it was his Neurowave project. I don't remember which one it was, but I saw he was posting some patches for it, so he's probably was using, or he's still using it. But most of the stuff you've seen here are quite possible using vvvv, so if you're interested in creating something like him, might be interesting. Some of these things I definitely don't know how to create one, but anyways, for today's tutorial we would need the DX11 particle packs. If you haven't followed, this tutorial is going to be a bit advanced, so if you haven't followed my previous DX11 particles pack tutorial, please follow those. You might get stuck in some point. Yeah, and if you don't have any 3D scanned data, I scanned my 3D data is this. So the scene from this one is scanned by my friend, and he was using some special equipment to scan my office. But so it looks like this, and if you change the rendering mode. So this is my office, and he 3D scanned it really nicely so that I could use it for many stuff. So this is where I work, this is my table, things like that. But if you're also interested in 3D scanning your place or something around you, there's a few different options for that. 3D Zephyr or this Agisoft Metashape, or I think there's another one I forgot. Oh no, this one is Agisoft Photoscan, and there's some few other options, and there's also smartphone free 3D scanning apps as well. I'm not gonna go deep in that part, but if you're interested, please look it by yourself. Okay, so that was it. Oh, and thanks to Burson.com, he mentioned me about creating this tutorial. So yep, so let's get started. So this is how the patch looks like at the moment. So I'm basically using the DX11 particle emitter geometry. What it does is you can import a geometry and convert the vertices to a particle. So this is the one that we're going to be using. And in addition to that, I have a few different things. This one is the one that's adding the turbulence. And I also created a different type of a technique, like so by using by changing the one from this one to this one, what it does is okay, how does it work? Just scale it up. So what it's doing here, so the one before, it was the turbulence were added based on the camera position, but by using different nodes, you can actually make it intersect. I think the lifespan for the particles are too long. you can make it intersect with the sphere, random sphere position. So right now, this, whenever the particles inside this sphere position, the particles will be turbulenced. So, oh yeah, and the reason why I'm sharing this technique is because I saw a really nice video on Vimeo. I'm gonna show it to you. Where is it? Yeah, it's one of my recent favorite music clip. This guy called Ki Junwoo created this one. He says he made this one using Unity, but something like this should be possible inside vvvv as well. This one is great. I'll put the link below if you want to see it. It's a really nice audio reactive particle music clip, and doing things like this should also be possible by using these kind of like intersect nodes. So I'll share that as well at the end. Okay, so let's get started. So I'm gonna delete this one and start everything from scratch. Now, first of all, as always, we need the batch monitor, and then render, and then I'll add an axis and grid. Okay, so for today's tutorial, we're gonna be using the emitter geometry. So there's only one for that if you look for it. So just left click this one and F1 and open up the help patch. I already introduced, I forgot to. So this is the, yeah, so DX11 emitter geometry. So this one, there's only one. Once you open it up, just press F1 and open up the help patch. I already explained about this one in the previous tutorial, but basically what it's doing is, it's for some reason it's not working well here. Yep. So what it's basically doing is based on geometry, it's emitting a particle. So I just have to replace this one and change it to a photo scanned geometry. If you output from 3D Zephyr or photo scan, you should get an OBJ option. So today we're gonna be working with OBJ. So what I would do for today is I'm gonna copy all these, Control C, and delete this one. Then I'll put it back here. So I don't need this one anymore. Okay, and then I'll connect this. Oh, this one is aspect ratio. Then I'll connect this one to the renderer. Then I'll connect this one here. Okay, oh, and I also need a camera for today, so I'll add a camera. So yeah, now right now in default, the particles are emitting from the sphere. So I'll change this sphere to a file geometry. I think this one is included inside the, oh yeah, DX11. So you'll need the DX11 as well to follow today's tutorial. Then I'll delete this one, connect this one, and then in my file name, right click here, and I'll choose the OBJ file that I'm using. So this is the entire data I got from my friend. So these are the textures, and this is the OBJ. So I'm gonna drag and drop and put this one here, and then I'll connect this one to geometry. So it takes a bit of time because it's a huge photo scan data, but once it's done, you should be able to see something like this. And let's see if everything's correct. So right now there seems to be sort of like effect added. I think that's the velocity, so I'm gonna delete the velocity. And here you go. It seems to be correct, but something is missing. Oh, I also don't need the texture for now, so I'll delete the texture. It seems okay, but I think something is missing, and that is, I think the vertex count from this geometry is not correct. And this happens quite often. What you have to do here is a bit tricky. Is you change this instance count to 0 and then change it back to 1 again. Once you do this, you saw that this vertex count changed from 90,000 or something, and this is you need to update the geometry buffer to tell him the right amount of particles. And then I'll connect this vertex count to emit count as well, because I want the entire scene to be emitted. So as you see right now, I'm getting the photo scanned scene. And if you're interested in adding the texture onto it, I'm not gonna do the entire process because I had to map all these textures and it was quite hard. And whatever software you use, they output different, like multiple textures. And this can basically, you have to do this mapping thing hand by hand. So I'm gonna skip that process since I already did that before. And I have a mesh importer node that has all the texture assigned. This is how it looks like, and you might be able to do something like this via your patch as well. Just try copying this one and see if it works. I think I'm using the scene file, and here's the obj, and then this info mesh async node is exporting the material index. This is the important one, so you need to know what index the textures are mapped, and once you have it, this directory node is outputting the entire texture from the folder directory, and I put that in the file texture, and I do get slice, and then I'm sorting all the texture from the index position. So once that's done, I should be able to have all the textures mapped. Takes a bit of time. For some of you who don't have a powerful PC, this might not work. Once this is done, you can sort of already see that the texture is mapped. But with this particle, it's a bit hard to see, so I'm gonna add a constant effect. And then I'm gonna connect this texture and geometry to constant and plug that to a group, just to see if it's all working correct. Yes, it is. So the texture is perfectly mapped, as you see. Look how nice my office is. It's a really old Japanese house. And we have a lot of digital equipment here as well. Okay. Anyway, for today's tutorial, I'm not going to keep it like this one. I'll add a rasterizer. Not this one. So there's two types, not advanced, this one. I'm going to connect a rasterizer and change the cooling mode to no-code wireframe. By doing this, I can visualize the mesh with wireframes, so this looks cool. Then I'm gonna change a little bit with this halo thing, because right now it's blurry and I don't like that look. So I'm gonna change it to really low amount, so 0.03. Now it looks way better. Okay, so this is like the default basic setup on how to import a photo scanned data into vvvv. So once this, if this was the goal for you, the rest of my tutorial I'm going to be explaining how to add an effect. If you're not interested, you can just finish watching this. Okay, so I'm gonna put this up. So what I'll be doing next is I'm gonna add some effect onto it, and to do so I need to add a group and then connect this, and this will allow you to add different effects. I'm gonna delete the render state and enable because I don't need it. Then I'll widen this up, and what I will do here is I'll add a selection node. So the selection node from particle selection. Okay, then I connect this in here. So now we have selection node here. And then I'll add, oh wait, I'll do something different. I'll add a box here, and then I'll add a constant. And then I'll connect this to this render as well, so I have this box visualized. And then I'll make this one a little bit bigger. So 0.01, 5 and 5. And then I'll add a translate 3D vector. What I basically want to do is I want this thing to sort of be like the scanner. So I'm gonna make this guy move from here, which is 15 to probably minus 15. So map value, and then the destination minimal and destination maximal will be 15 to minus 15. And then I'll add an LFO here so that I have a value mapped between 15 and minus 15. I'll change this one to 20. And then vector 3D join, and I'll add this one to the X vector. Okay, now I have a really nice scanner. I think I'll add a little bit of Y-axis. Okay, so I'm gonna let these particles, how do you say, emit. Wherever this white box passes, I'm gonna let that part add a turbulence effect. So I'll make this part a little bit clearer. Move this guy to the bottom. Okay, so to do so, what I have to do is, first of all, there's selection node, and then I'm gonna add a turbulence. I'm not gonna create the entire node. I don't want to work on everything always, so I just copy these one from the help patch, and then copy it here, paste it here, and I'll delete these texts, and then I'll connect this turbulence to selection. So this is the first part. Now you see the turbulence is added to the entire scene, but I have to add a selection selector node. So what I would do is select particle, and then I'll go through to find out the best node for today. Yeah, this one. So I'm gonna be using position dx11 particle selection. And then I'm gonna plug the selection position node to the selection. And then you can choose different types. I'm gonna choose, I think this one is on x-axis, so if it's greater than x-axis, then I'm gonna let it turbulence. So right now you can see that I think this middle part is, I think, seeing things 0, and the right part is plus and the left part is minus. So what I'm gonna do is I'm gonna connect this map output to position threshold. Once this is done, I'm gonna reset the particles and see if it's all working. Okay, so we already got this effect, the scanner effect. But I think the lifespan for the particles is a bit too short, so I'm gonna output this LFO, and then I'm gonna connect this one to the lifespan. Oh, and I also want to reset the LFO, so I'm gonna connect this one here. Oh, where's the particle? Okay, I don't know why. I think this is sort of like a bug, but in my place I have to press it several times to. Okay, so as you see, now we can see that this particle is being emitted whenever this quad is passing. So this is the result that we wanted to have for today. I'm gonna clean up this patch a little bit to make it look a bit easier. So I'm gonna delete the render state and enable, and then I'm gonna make this one bigger. I think I'll make this one a little bit bigger as well. It's always good to clean up your patch. Then I'm going to put this on above, because this is the important one. I don't need this velocity from normal, so I'm going to delete this and put this lifespan right here. I want a straight line. And then, so this is the reset thingy, so I'm going to put it here, and then selection is here. I'm gonna make this guy a little bit wider. All the values here. Extruder. Okay, so Now you should be able to see what's happening. So this reset is resetting whenever I press the particle system and the LFO. And then this is the time for the particle lifespan and also the LFO. Okay, so we're getting really close. So this is the basic setup. And once this is done, what I'm gonna do is I'm gonna delete this box. And then instead of the box, I'm gonna let the camera follow. So I'm gonna put the camera at the position where the boxes were. So I pressed R left click to reset my camera position. And then, oh wait. Yeah, it's camera position. And then I'll get the camera intersect. So this one out. Then I have to, okay, so I have to change the x-axis. So it's basically the same as this one. I'm gonna connect this guy here. Okay, here we go. We're done. You can see that the turbulence is added whenever the camera passes. That was quite easy. I think there's one thing missing. I think right now the turbulence is happening behind the camera, so you don't really see like the turbulence is being added. So what I'll be doing here is I'm gonna connect this minus node to here, and for the position. And then now I think I'll add a little bit of value. So let's say 1. And then I'll reset everything. Do it several times to let the particle show up, because right now I don't see it. Come on. Hi. Oh, there you are. Yeah, we have to stay calm for this. I don't know why this keeps happening. Come on. Okay, there you go. So let's see if it's all working. Okay, so I added minus here so that the particles are turbulent like a little bit before my camera. So by doing this, you get that really nice effect based on the camera position. Okay, so this is basically what I wanted to share for today. In addition to that, I'm gonna share how I created the other one. And that one is using the node called intersect. Or maybe this is good for the homework. So there's a node called intersect. So this is intersect particle selection, and I think I used the transform. And then let's press F1 and see what this does. Oh no, I used the other one. So I used the intersect vector 3D. So what this does is basically like it intersects like whatever particles is inside this intersect area. You can add, like this one is adding a color. So what you basically have to do is you just have to connect this and replace it with the position, and then add some random spread to get a random position for this part, and then you should be able to get the result that I was showing in the beginning. So I'm not going to go deep in that. If you get it solved, I'll be really happy. But anyways, this is how you could import photo scan geometry and add some nice turbulence effect depending on your camera position. So that was it for today's tutorial. Thanks for watching. Oh, I have my camera off. Okay, so that was it for today's tutorial. Thanks for watching, and see you next time.